Welcome. My name is Josh Almeida, and I am very excited to bring to you our latest installment of Focus on Learning, brought to you by New Bedford Public Schools and New Bedford Cable Network. While the best way to find out what your child could be doing at home is to work directly with your child's teacher in school, we know these videos will help everyone keep learning active at home.
Hello everyone, I'm Mrs. Andrade, a third grade teacher over at the Lincoln Elementary School, and I'm here today to go over some key points in vocabulary that will help you to complete the math packets that the district has been sending home. I'm going to start off by reading you our objective for today. Students will identify the relationship between multiplication and division by using properties to solve equations. So that's what we're going to be focusing on, the relationship between multiplication and division. Let's start off here with our example. Jenny draws 8 cartoon bugs with 10 legs each. How many legs did she draw in all? We can write an equation for this. We're going to first underline our important information. There are 8 cartoon bugs. There are 10 legs each. That's an important word. How many legs did she draw in all? So our equation is going to use the important information that we've underlined. So we're going to write down first the 8 bugs. Then we're going to write 10 legs each. 10 legs each. Now by writing legs each, that kind of is a clue word that we're going to be using multiplication. Now how do I want to solve this is what we're going to work on. There's lots of strategies that you can use. We can use skip counting. These are 8 bugs, so there are going to be 8 groups that we're going to be counting. We're going to have 8 groups, 3, 4, 5, 6, 7, 8, and there are 10 legs in each. So I'm going to be counting, boys and girls, by 10. 10 for the first bug, 10 more would be 20 for the second bug, 30, 40, 50, 60, 70, and 80. So if there are 8 bugs and I'm counting by 10s each, there should be 80 legs in all. I'm going to show you this with a different strategy. You might want to use a number line. A number line is not difficult to do. You draw yourself a straight line. You start off with 0. And we're going to do the same thing. The bugs are going to be the number of jumps. Those are the groups. The legs are going to be what we're counting by. So I'm going to be counting by 10s 8 times. So my first jump for my first bug would be 10. My second jump would be 20. That's 2 bugs. My third jump would be 30. 40, there's 4 bugs. 50 is 5 bugs. 60 is 6 bugs. 70 and 80. So I have 8 jumps, 1, 2, 3, 4, 5, 6, 7, 8, with 10 in each. 8 jumps of 10 represents the 8 bugs and the 10 legs. I could also have drawn an array. This would take up a little bit of time because it's such a large number, but you could do it. Your bugs would represent your rows, so you'd have 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. You'd be going across, there's 10 legs in each, so 2, 3, 4, 5, 6, 7, 8, 9, 10. That's my first bug. This would represent my second bug, another 10, another 10 for my third, another 10 for my fourth, and so on. So you'd keep making your array. These are the rows, those are the bugs, the columns are the legs. So at the end, if you were to count these out, you would also have 80. Just another strategy that you can use for multiplication. So I have 8 bugs with 10 legs each. And then at the bottom, the last one would be to draw a picture. You could definitely do that. You could draw out your 8 bugs. You don't need to draw the 10 legs. You could put the number 10 in each so that you're saving yourself time. And then you count. There are 8 bugs with 10 legs in each. So these are the strategies that you can use to solve the problem. Excuse me. Now that we know that, we're going to move on to the commutative property. Now that you know how to solve the problem, it's important that you understand the commutative property. You can change the order of the factors in a multiplication equation, and the product will stay the same. The answer will stay the same. I'm going to show you an example here using 4 times 5. If I have 4 times 5, what does that mean? It means 4 groups of 5. 4 groups of 5. If I have 5 times 4, it means that I have 5 groups of 4. What you're going to see, we're going to show you through skip counting because it's quicker, that it doesn't make a difference if I do 4 groups of 5 or switch the order and do 5 groups of 4. My answer will remain the same. So 4 groups of 5. I'm going to draw the groups, 1, 2, 3, 4, and I'm going to count by 5s. 5, 10, 15, 20. So 4 times 5, I get a product of 20. Let's do 5 groups of 4. 1, 2, 3, 4, 5. And I'm going to count by 4s. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20. So it didn't make a difference, boys and girls, which way I went. Skip counting 4 groups of 5 or 5 groups of 4. The order didn't change my final answer. So now that we know that, we can use our fact families to help us with our difficult facts. What is a fact family? A group of related multiplication and division equations using the same 3 digits. So let's look at our 4 times 5. We know 4 times 5 is 20. We did that up here. So if I wanted to show the facts, the equations that are in the same family, I've got my commutative property here. I can use 5 times 4 to get the 20. Now I need 2 division equations. Division equations would start with our product, the bigger number, and we're going to divide it by the numbers that we have here, the factors. So 20 divided by 4 would equal 5, and 20 divided by 5 would equal 4. Sorry about that. So we have a group of related facts, 2 multiplication, 2 division. Those are called fact families. Now that we have that knowledge, you can use this relationship to find missing numbers in equations. Let's try one together. We have 15 divided by 3. How would we tackle that problem? You could use a multiplication. Something times 3 would equal 15. Ask yourself, how many groups of 3 will equal 15? Let's skip count. Let's start counting by 3s and see how many groups we get. So I have 1 group, 3, plus another group, 6, 9, 12, 15. How many groups is that? 1, 2, 3, 4, 5. There are 5 groups. 5 groups of 3 equal 15. So that tells me that if I have 15, I divide it by 3, I will end up with 5 groups. This is where fact families come into play. You can figure out the difficult division problems using multiplication. Let's try another one. What if I have a division 24 divided by something equals 4? We've got a missing number. Something times 4 will give us that 24. Ask yourself, how many groups of 4 equal 24? Let's try it out. And you can use any strategy. You don't have to use skip counting. You can use your number line. You can draw a picture, an array, whatever you feel comfortable with. So 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus another 4 is 24. How many groups is that? 1, 2, 3, 4, 5, 6. So 6 groups of 4 equal 24. That means that 24, the missing number is 6. And we can keep going. We can go on and do these other missing numbers using division to figure out the missing number. Let's try these last 2 quickly. Something times 5 is 30. We don't know how many groups. Here's our fact family. 30 divided by 5 equals something. How many groups of 5 go into 30? 5, 10, 15, 20, 25, 30. 1, 2, 3, 4, 5, 6. So we have 6 groups of 5 go into 30. 30 divided by 5 is 6. Last one, something times 3 equals 12. 12 divided by 3 would be the division that we would use, the same fact family. Count by 3s to 12. 3, 6, 9, 12. We have 4 groups. So if 12 divided by 3 is 4, then that tells us that 4 times 3 equals 12. So before we finish with the lesson, I want to talk to you about something that you're going to see in your packet. There's going to be a chart that asks you to fill in what you've learned about fact families. So you want to ask yourself, what is a fact family? You want to ask yourself what you know about it. And then they're going to ask you for 3 examples. So what is a fact family? A fact family is a group of numbers that are related with multiplication and division. So a group of related multiplication and division equations or facts. You can call them equations or you can call them multiplication facts. The important thing to remember is that they're related. What do you know about them? What do you know about fact families? We know that they use the same 3 digits. So I know that I can use the same 3 digits from one equation to solve the others. That's what I know about fact families. So I've identified what it is, what I know. Now they want 3 examples. So we're going to show 3 different things that we've learned with fact families. If I'm given an array, if I'm given this array, can you write a fact family for that? Sure we can. There are 2 going down, 2 rows, 3 columns. So that would represent 2 times 3 equals 6. I learned the commutative property, I can switch it. 3 times 2 will also equal 6. I know that if I take my product, I can start my division. So 6 divided by 2 will equal 3. And I can switch the factors. 6 divided by 3 will equal 2. That's one example showing a fact family. Another example that we talked about was missing numbers. So for example, if I gave you an equation, 3 times blank equals 21, I know I could swap those. That blank times 3 would equal 21. I could write a division. Start with your product. 21 divided by 3 equals blank. And then 21 divided by blank equals 3. This would be an example of missing numbers. Whatever number goes in that box would be the same, which in this case would be a 7. 3 times 7 is 21. 7 times 3 is 21. 21 divided by 3 is 7, and 21 divided by 7 equals 3. The last example that we're going to write down, we've talked about arrays, showing the fact family, showing the missing number, and also that you could write it as a sentence. I can use the multiplication fact (5 times 4 equals 20) to find 20, to find the answer to 20 divided by 4 equals blank. So I can use the multiplication fact 5 times 4 to find the answer to 20 divided by 4. I know it would be 5 because I know that 5 times 4 is 20. So these are just some different tools that you can use, some strategies, properties that will help you when you're working at home and you're trying to get through those packets. They're not that difficult. It just requires you to take some time and think about it. And I hope that you're all working hard. I hope that you're putting in the effort. And I know that the teachers are. And we look forward to seeing you before the end of the year. Have a great day.